Good evening, everyone. Welcome to your weekly tour around your celestial neighborhood. I'm Irene Pease, super excited to to be here. For some reason, it says it's been live for 10 minutes. Hope it didn't hear me singing. Anywho, we're gonna get started. It should be fun, I hope. Um, yeah. So so tonight, for March 4th, I decided since it is March 4th, we should all dare mighty things. And I feel like I'm kind of daring something every week when I try to do this, fending with the Facebook and trying to make it bend to my will as best I can. Um, so, thanks for joining me. We are going to be going to the edge of our exploration as human beings, as far out as we've sent objects, our robots, into space. So excited for this. This is also kind of the last of an informal mini series. I've been teaching a super fun class for the Amateur Astronomers Association, which you can find out more about that at aaa.org. And we've been talking about current missions, so things that we've sent out into space that are still out there now. And this was the last week. And so I've been doing kind of these follow-ups for the class each Thursday, but class is over, so we might actually leave the solar system next week. We'll see what jives. Anyway, same visuals as usual. We have Stellarium, which you can find at stellarium.org. And in the background right now, Open Space, which you can find at openspaceproject.com. Super excited. Got all upgraded, running Open Space 16 tonight with the new fancy menus and stuff. So really excited about that. Anywho, we'll go ahead and pop on over to the Stellarium and see what's up in the sky. If we have a sky, yep, there's a sky. Wonderful. So there's our fake dark Brooklyn sky. Brooklyn's not really that dark unless there's a blackout. Hoping not. But we've been looking at a lot of constellations over the winter. We're going to be focusing a whole bunch on Orion in a couple weeks with a special guest co-host, Kuiper Cat. So she'll be taking us through a whole bunch of really cool stuff, all the stuff that I've kind of glazed over. Really thorough tour of Orion in a couple weeks. But for tonight, I wanted to look along the edge, since we're going kind of to the edge of, well, our solar system. I thought we'd look at, oh, there's the galaxy edge on. That's my connection. I know, not the best, but it's what I've got. So another winter constellation that's right in the plane of the Milky Way, as seen from Earth, is this kind of pentagon-shaped thing up here. So you kind of have to go up above Orion, north of Orion, so to speak. So if you kind of follow the direction of the sword, up past the shoulders, the armpit Betelgeuse, and the other shoulder Bellatrix, and keep going. In a dark sky, you might see the Milky Way kind of as a haze through there, but this is not the thickest part by any means. So a little bit tricky to see if you don't have a super dark sky. But up here we have Auriga. So Auriga, our charioteer, inventor and big fan of goats. So also kind of cool that, you know, the kind of innovation and invention of the four-wheeled chariot, whatever. But also just a nice constellation because, of course, it has a lot of sparkly things like you do. Some kind of neat asterisms that you can see. A couple bright stars along here, the fishes or the trout in a stream. And there's this big Cheshire cat or smiling grinny frog or whatever you want to call it. The nice little curve of stars and then like two eyeballs. So make of that what you will. That's what I like to use to find the three big Messier objects up there, M36, 37, 38. So you can already start to see some fuzzy spots. So 1, 2, 3 open clusters from the Messier list. I don't actually call them the starfish, etc. But yeah, so the probably least dense one is 38, but also a little bit easier to find. So if you follow kind of the fishes, which you can see naked eye in a dark sky, follow that with binoculars over to the smile, and then up here, even in binoculars with a dark sky, you can see a nice cluster there. And then if you look straight below the smile, so to speak, so find your eyeballs, look below the smile to M36, a little bit more dense. And then my favorite, of course, is the hardest one to find, M37 over here, which it's not going to tell me that's M37, but a little bit further away, M37, really nice, dense with these kind of bright stars. And I think that's, I hope I'm not lying. Yeah, the reddish one in the middle. So some really nice star clusters. Try and pick them out with binoculars, or if you have a telescope, you can see a little bit more detail. Even just with the naked eye, see if you can pick out the pentagon. Capella is super bright. It's one of the brightest stars in the night sky. But there's the 5 stars that make up Auriga, and this little kind of thin isosceles triangle over here, that asterism is the kid, because again, this person is supposed to be a big fan of goats. So that's kid as in small goat, not small child. Yeah, supposedly a person, bright star Capella, and then a little asterism that makes up a goat. Also, remember last week I mentioned, I think it was last week, feels like forever, Vesta. So I am a little bit tired. I probably won't go out tonight. It's looking clear tonight. Remember, the 8th is the closest approach. It's looking a little bit hazy, I think, for next week. But I'm probably going to go out tomorrow night with the telescope and try and pick out Vesta, kind of in the back part of Leo. So good luck with that. Let us know if you have seen it in the chat. I'd be very interested to see if anyone has found it from inside the city or nearby. Yeah, share your notes. But that's it for this week. So see if you can find Auriga, if you can find some of the clusters in Auriga, and we'll be back with more fun things in their night sky next week. Hopefully tales of spying Vesta. That's the goal. So back on over to open space. Oh, look, space. So again, you can download OpenSpace for free, openspaceproject.com. And this is all like real data that's loaded in here. So you can just fly around in 3 dimensions and explore the universe. Really fun. So already we have a couple lines jutting off from Earth. So right now we're kind of a bird's eye view of the solar system. And yeah, we're just going to see if we can track through this in the next 20 minutes or so. So we have the orbits of the inner planets: Mercury, Venus, Earth, Mars, and you might be able to say Earth has a couple things sticking off of it, like little antennae. So the date that this is actually set for is not right now, so we're traveling through time and space. Not quite a TARDIS, but I guess the closest thing that I'm ever going to have to a TARDIS in my bedroom. So if I go ahead and focus on Voyager 1, we're going to be following these marvelous missions through many extensions. So these missions both blasted off from Earth. Voyager 2 actually launched a little bit earlier than Voyager 1, but on a slightly different trajectory. So you can see Voyager 1 is already kind of out there. It's going to be heading out. Let's go ahead and turn on some time a little bit faster than 1 second per second, because we don't have 50 years to get through this. So we'll do a few months, more than a few months. So we'll step that up. And maybe that's a little fast. So if we move out a little bit, we can see where they're both headed. Oh, and I already missed the first target. So Voyager 1 was the first to reach Jupiter. Just kidding, that's not even Jupiter, that's Saturn. Let's go back a couple years here. a little bit carried away there. Yeah, So launched in 77, and shortly thereafter, here we go, reached Jupiter. So I want to do kind of a fun flyby. I thought it'd be fun to do like a little bit of a flyby through the Jupiter system for Voyager 1 if we step back a few months. So it got there in early March. So here we are right now in very late February. And just kind of follow Voyager 1 through the system because it was kind of amazing. It actually got pretty close to a couple of the moons. If we fly in here, we can see the probes itself. So they're basically twin probes. They look pretty much the same. And again, I'm just going to keep saying this, how amazing it is what we were able to accomplish with technology from 1977. Again, these launched in 77. So start doing math in your head. There's going to be a quiz at the end. Not really, but maybe. If we ever get in there. Oh, there it is. Found it. Found a Voyager. Okay, so we'll step through this a little bit more slowly. A few days at a time, I guess. So it got, there had been a couple other missions past Jupiter and Saturn, but this actually got some nice images of the moon Io as well. So we can slow down even more here. Just a few hours. Yeah, and just kind of cruise through the Jovian system. So, whoa, that's even still really fast. So past Io and then right past Ganymede as well. And it was gone. So didn't slow down, didn't stop to say hi, just flashed a whole mess of pictures. And then it was on its way again. So huge, as we saw in the class, this thing, you know, in order to communicate back home, to phone home, has this huge satellite dish, basically this huge communication dish. It's 3.7 meters across. Magnetometer, those are the big long things sticking off of it. And we have no solar panels because it's going out to the far part of the solar system where there's not a lot of sunlight, but we have our RTG, so our radioisotope thermoelectric generator. So these three blobs right here. So a lot going on here, but basically built to last for 3 to 4 years, right? So we'll go ahead and pick up the pace to get out to Saturn and maybe pop by our Saturn system a little slower out there. Actually wrote down some. Did I write down? I thought I wrote down how fast to go. Oh yeah. Yeah, I went too fast through that one. We'll we'll cruise a little more casually through the Saturn system. So just flicking through the months here, we can see. So it took a few more years to get out to Saturn. So the March that was, or sorry, the Jupiter that was, yeah, just a year or two, or what, 79. And then you can see Jupiter, or Voyager 2 hit Jupiter, and then we're getting out. So a couple years later in 1980, uh-oh, I broke the, oh no. Don't panic. We've got this. Might have to reset something. I think I went too fast through time. Yeah, went too fast through time. So we're just going to reset this for real quick. And you can just enjoy the happy pink lettering there for a moment. One of these. one of these. Fortunately, OpenSpace 16 has a nice little startup window that's oh so friendly and should get us there in no time. Yeah, we're there. So yeah, it's kind of like, the TARDIS doesn't always get you exactly where you want to be, and when. But let's try that again. All right, so back to our open space. See, no panicking. It's all good. So we'll just kind of casually sift through time. One of those. One of those. And then a few more months. So yeah, so it was so our Saturn approach, just kidding, Saturn was November for Voyager 1, and then the following August for Voyager 2. So here we are in mid-October, and we'll just kind of zoom in again to Voyager 1 and play through time a little bit as we approach the Saturnian system. So the closest it got to Saturn, I mean, it's still like tens of thousands of miles away from these planets. Jupiter, the closest it got was 174,000 miles, which is a lot, but Jupiter is really big, right? So, so just as a reminder, the year is now 1980. So yeah, I'm alive and kicking. And here we are coming up on the Saturn. So again, I just love being able to kind of fly by these. The Voyagers collectively found a few more moons around each of the planets. More details in the rings, especially in the rings of Saturn, because Saturn has such a complicated ring system. So finding some of the bumps and bips and things in there. So we're just going to kind of cruise through here. Let's try this. Less than an hour per second for now. There we go. Coming up on the Saturn. So, yeah, so early 80s. And again, yeah, November. So if you think about what you were doing in 1980, basically the Voyager missions were supposed to be starting to end. So the original missions were Jupiter and Saturn, right? So two gas giant planets. And of course, people had in the back of their minds all along, and we're kind of, sort of unofficially planning for it, but, potentially on past these two giants and out to planets that we had not visited before. So they were doing well enough, they had plenty of power, plenty of gumption, plenty of popularity, I guess, to get the funding to be extended past this. So this was kind of not the end, but a new stage for really both Voyagers. For Voyager 1, which we're flying by here, so we got a nice view of, pretty sure that's definitely Titan. So, woo! Hello, Titan. Don't crash! Okay. So, really close view of Titan there. And then, so I think that was only a few thousand miles from Titan. And then again, about 78,000 miles from Saturn here. We can pick up the pace a little bit. But then Voyager 1 used Saturn to slingshot. So we're going to go kind of below Saturn, the southern hemisphere of Saturn. Take pretty pictures of Saturn. Click, click, click. Oh, wow, look. Saturn's southern hemisphere. And then whoosh, and we're going to fly up and out of the plane of the solar system. So Voyager 1, the next stage of its journey is going out of the solar system above the northern plane, so north of the solar system. Hence the trip kind of around Saturn's southern pole. So that's its next stage, is it's going off to see some stars. So it's taking all kinds of cool pictures and stuff, still of the Saturnian system as it's headed out of there. But that's going to be kind of the end of the planets that Voyager 2 will be visiting. So let's pop back on over to Voyager 1. Or sorry, that's Voyager 1. So let's pop back on over to Voyager 2. And we can see Voyager 2 over here. So Voyager 2 followed Voyager 1 to Jupiter, followed Voyager 1 to Saturn. And if we kind of click through the months, it got to Saturn again in August of 1981. So here we are in March 81, April, May. So intersecting in August, and then a slingshot out, still in the plane of the solar system, although I don't know why it's crashing again. That's kind of uncool. Still not panicking because this worked half an hour ago. It worked this morning and it worked half an hour ago. Not sure why it's doing that. So I'm going to give it one more go of resetting. So basically, Voyager 2 is then off and running to the ice giants. So I know when I went to school, I learned about the giant planets. So there was, Jupiter, Saturn, Uranus, and Neptune were giant planets. And then now we have kind of ice giants and the gas giants. So our ice giants are made of more ices. So that's like Uranus and Neptune. And Voyager 2 is still the only object, the only craft to have visited them. And that was like back in the 80s. Both events were kind of overshadowed, kind of not. I don't know if they overshadowed. There were other things happening in the world as Voyager 2 arrived at both of those. So I'm going to try tackling this from a slightly different angle and just see if this will let me go past that date. So we're going to zoom out 79, 80, 81, 82. Ideally, we'll get to 2016, but if not, that's cool. And I don't think there's any other games happening on my computer right now. Hoping not. All right, so we're at 85. We'll go to 86. Yeah, went to 86. All right. So we'll step back to early 86, January of 86. So for those of you who are around in January of 86, yeah, other things brewing. But let's go ahead and stop by our Voyager if we can. If I can target Voyager 2. And its pass at probably one of the most mysterious planets, one of the most interesting and, I don't know, rebellious kind of planets. The cool thing about our view of Uranus here is you see it kind of face on, so to speak. So Uranus takes such a long stinking time to go around the sun. Sometimes it's like this big bullseye, like really like a bullseye in the sky, just, really far away. And then sometimes it's going to be a little bit more edge on because of its extreme tilt in our solar system. So we'll just kind of run through a little bit of time here, a few minutes to see our Uranus flyby. Because really, how many times do you get to fly by Uranus? So far in all of history, once. That's it. So found a few more rings of Uranus, a few more moons, discovered this kind of wonky magnetic field and all of its strangeness. So really Uranus was basically more questions than answers. That's what we get a lot, I feel like, when we go exploring things, is getting a lot more questions than answers. But that's fun, right? And that's what scientists like to call job security. So we'll go about, if we're doing about 30 or so minutes per second, you can really see a lot more of the moon. So we'd only seen a few of the moons from Earth before the Voyagers got there. But a little bit more information about the clouds, the contents, and again, it has these wonderful magnetic field detectors. So we could just kind of zoom through there. This was a pretty close approach, about 50,000 miles away from Uranus. But again, this was at a cool time when it was kind of like facing right on like that. So really pretty to watch. And I think Uranus actually has a little bit more personality than we usually show it, with this kind of pale, like kind of blank clouds, really. There's a lot going on with Uranus. So I'm all about, like, going back. I understand it's really far away, but it might be a nice thing to do, in all our spare time. Get a little bit of spare change, throw it at Uranus. One of these days. So that was our Uranus pass. So, yeah. So beautiful pass to Uranus. And then that was early 86, so January 86. And then the next time it reached another planet, the last planet on its journey, not the last planet in the solar system at the time, but the last planet on its journey, wouldn't be for a few more years. So 3 more years then to get from Uranus all the way out to Neptune. So if we kind of step through 86, 87, 88, and it was late summer of 89. So think about what was happening in 1989. And it was August, so late August, 1989. So what were you doing in 1989? Anything exciting? Hoping yes. Oops. And we just missed it. So we'll go back to the 23rd and zoom right in. Woo! For our pass of Neptune. So Neptune, again, last kind of leg of this part of the extended journey. 89, kindergarten for some. All right, so there's our dish still pointed back at Earth, so it could still send information back to Earth, handy dandy like. But yeah, so we got very close to Neptune because this was going to be its last kick. So with each of the planets that either of the Voyagers passed, they got an extra kick to speed up. We got what we call a gravity assist. So for this last gravity assist, it's going to pass super, super close to Neptune. I promise it's not going to crash into it because that's not what happened. But it's actually going to pass just 3,000 miles within 3,000 miles of Jupiter. Or I know my planets. And it's gone again. Within 3,000 miles of Neptune. So it goes around the, spoiler alert, it goes around the southern pole of Neptune, like super, super close, in order to get a kick to go up out of the, did I do that right? No, above the northern pole. Northern pole, to get a kick to go out of the the plane of the solar system to the south. So Voyager 1 going north, Voyager 2 going south from the plane of the solar system. And I said I wasn't going to give this another go, but we're just going to fast forward to the end here because I think it makes a nice point. And I'll just chit chat for another minute. If you'll bear with me. So we have these Voyagers that are now some of the most distant objects that we've ever sent out. It turns out Voyager 1 is the most distant object that we've ever sent out. It's so far away that it takes light over 21 hours to travel one way. So we are still in communication with both of the Voyagers. So I'm just going to center this on the sun again, and we'll step very carefully through time. Very delicately, tiptoe through time. So both Voyagers still pinging back. Their power supplies are still functioning, still in power, and still communicating a little bit. So again, Voyager 1 is 152 times the Earth-Sun distance. So 152 astronomical units out there. Voyager 2, about 126 and a half astronomical units out there. And they're both traveling several astronomical units per year. So those are actually the fastest things that are moving outside of our solar system, moving away from the sun. And here you can start to see the lines, one going north. So there's Voyager 1 going north, and then Voyager 2 going down and to the south. So if we step through time a little bit further, I'm not going to risk trying to zoom into it. But along about 2006, we get another mission sent out, which is pretty exciting. And that's, of course, New Horizons, which visits a dwarf planet. So it's launched on its way to a planet, ends up visiting and passing by the largest dwarf planet in the system 9 years later. So it took the Voyagers 12 years to make it out to Neptune. So Voyager 2 took 12 years to get out to Neptune. New Horizons got to Pluto in just 9 years, which is pretty impressive, like super impressive. It got a boost from Jupiter, so it did a gravity assist around Jupiter. And it's still going, but it's still pretty close in there, a lot closer in than the Voyagers. So here we're at 2013. So similar to the Voyagers, New Horizons does not have big fancy solar panels. It has the RTGs, the radioisotope thermoelectric generators, and it's supposed to last probably 60 to 70 years. So again, the Voyagers, there we're talking 1970s technology. New Horizons was sent out with early 2000s technology, so much newer technology. So that one's going to last a little bit longer. Smaller dish, so hoping it'll still be able to kick a signal back here, because the New Horizons dish is only, 1 point something, I think is less than 2 meters in diameter. But the Voyager dishes are 3.7, so close to 4 meters in diameter. So they're both still radioing back, and if they're very careful with the power, they might actually be able to make it last to 1927, which would be amazing. One, it's a big anniversary for those of us in the AAA, and two, that would be the 50th anniversary for the Voyagers. So things that we've been able to do with, again, 1970s technology, thinking about how far we've come from there and like the possibilities of what we might be able to do in the future. And as Brian's saying, yeah, our listening dishes here on Earth have gotten better. So yeah, so the Voyagers are still communicating with the NASA Deep Space Network. So if we can build bigger dishes to collect information from those, we'll be able to hear even further into the future. So kind of an edge, kind of going forth, seeing what we can blast off into space, into our local universe, really our celestial neighborhood, as I like to call it. But that's as far out as we've gone, and that's definitely all that we have time for tonight. If you have Stellarium, you can find more fun things in the sky. Download Stellarium at stellarium.org. And if you download OpenSpace, openspaceproject.com, you can fly around this, visit the New Horizons probe, and see all the fun things on that, just like we did with the Voyagers. So thanks to those visuals. Thanks everyone for tuning in for this kind of mishmash and kind of quirky, TARDIS-y trip through space and time of daring, mighty things. I'm Irene Pease, your friendly neighborhood astronomer. Thanks so much for joining me for your weekly tour around your celestial neighborhood. Have a good week. Clear skies out there. Be safe. Don't forget to wear a mask.